Okay, so for the first session for this course, we will look into the overall structure or the overall framework that we want to study berkaitan dengan machine learning ini lah. Okay. So today's plan is to get an overview of machine learning, and we look also the cost logistic and a brief introduction to machine learning. Okay, so most of you, not most of you, I think all of you have to propose your final year project, right? So some of you have proposed machine learning related work. This course will be a good course for you to explore what kind of project that you can do for your FYP. Okay, so why do you need to learn machine learning? Of course, this is part of the requirement that we um, ask the student to take. But the second part is nowadays most people want to learn machine learning. Even people from other faculty, for example, medic or uh, aquaculture, biotech, they wanted to learn how they can utilize or leverage machine learning in their work or in their research. Okay, so people like us, we will assist them. So for computer scientists, we learn the proper way of use machine learning to analyze or to extract hidden knowledge from massive amount of data, okay, or to produce an application that has some kind of intelligence. So for this course, it will give you an overview of machine learning. If you look at people in agriculture, they are looking into how they can forecast the production, or how do they predict the quality of crops that they have, or how they can predict what is the best crop that can be produced based on the analysis of the soil, the condition of the soil. So basically what you have here, we have three parts. Okay. So we have this data acquisition. This is where you capture the data. Okay. So you can get the data from remote sensing, from the satellite, or you can go out and take the data, collect the data, or you can take from the sensor, or you can take from the camera, hyperspectral camera, or you can, yeah, this one you get from the sensor. Okay. So basically what you need to know is how do you get this data, and then filter which data are more relevant with respect to um, the task that you're given. Okay, so in the second part is we need to process the data. Okay, so we need to process the data. For example, we need to clean the data. We need to remove the missing data, or we need to replace them. Okay? So in most cases, for data collection and data processing, it will take you 80% of your time. Okay? So once you have prepared the data, you keep them in the database. So you learn about database before, how to create them. So how do you extract, how you do retrieve the data. So once you have stored them in the database, or you have them in a separate file, then you can use machine learning to perform some of the tasks. For example, you want to predict the production of your um, paddy production, or you want to perform classification. How do you predict the quality of certain item, or you want to classify fish with disease and without disease? Okay, so once you be able to model your data based on the task, then you embed them in certain in any application, for example, mobile apps, or you can have um, web-based application. So people can use that one to perform prediction, forecasting, segmentation, and many more. So basically, you have three parts. So in this course, you will learn, if possible, all these phases, three phases, where you capture the data, and then where you model, and then where you implement the GUI or the mobile apps. Okay. So if we look at in the other field, for example, in healthcare, you can use this one to identify and diagnose a disease. So this is classification, okay, positive or negative classes. Or you can personalize medical treatment based on the history that they have, meaning that you look at the history, then you want to personalize the treatment based on your data that you have. You can also predict disease based on the data that you collected from the public or from the environment. Then you can predict whether there is an outbreak of disease. Um, some of them use machine learning to look at the structure of the drugs, the protein. They look at the similarity between a few protein in terms of the structure or the content. We could also use machine learning for medical imaging, in which you use deep learning to classify images. Okay? And in education, we can also use AI to be personalized tutor for the student, depending on the pace of the student. So student will get more advanced, what we call it, timetable or curriculum. So slow student will get more basic or more explanation of the topic that they want to learn. Okay, so we can also use this one for grading or lifelong learning.
But the slide is not moving.
Not moving.
Yeah, there's still this slide one.
Slide one. Okay, let me. Let me stop. Screen. Okay, boleh nampak?
Boleh.
Boleh. Next slide. This one, boleh?
Boleh.
Okay. So let me repeat this one briefly. Basically, in machine learning, you have three parts, right? This is data collection. This is data pre-processing. So most of your time will be spent in this two areas, lah. Okay? So once you get the data process. Then you start the modeling. This is where you train your model or perform the classification or forecasting or segmentation or trying to do the market basket analysis. So these are some of the functional. So once you train your machine learning, then you can develop a GUI or mobile apps for user to use your model here. Okay. So these are some of the area where machine learning can be leveraged in order to improve the services. This is in education and okay. So what we can say that machine learning is everywhere. So the good thing about this thing is that when you graduated from this university, then you have ample of company to hire you, but you must be good. Okay, so you know what to do, how to analyze, how to develop mobile apps that you utilize or leverage this machine learning to perform some of the tasks that we have. Okay, so for the course learning outcome, we have three basic learning outcome. The first thing is to be able to explain the concept and the technique in machine learning. So you have to know how many tasks we have, okay, and how many type of machine learning we have. And at the same time, also you must be able to do or go over the hands-on practical so that you can use this machine learning method to solve real-world problem. And the third one is not only understanding, but you're able to explain the model and evaluate which model is best for your task. So this will be tested. So basically, this one will be tested for your in your tests and also your quizzes, and this is in your assignment and also the project. And lastly is the exam. Okay, so most people they can score here and here, but then in the final exam they fail to apply what they have studied here. Okay, so this is what we will cover. So today we will cover introduction to machine learning, and then later on we will cover more on this one. I may have to add one more here, which is the market basket analysis. So depending on our schedule. Okay. So this course is for me is very interesting because you will learn enough model for you to think about what project you can get involved and then assist people in their tasks. And for your assessment, as usual, so your assignment is 20%. This practical is actually a project. Okay, so you will have to do your own project. Quizzes 10%, midterm 20%. So this is a big percentage here, 40%. Okay, so as usual, if you cannot attend the lecture, you need to provide short course letter. Some of you may not able to submit the assignment on time, so I allow you to submit late, but you will have 50% deduction. Okay, any question?
No document.
Okay, so we proceed with the overview of the machine learning. So what is machine learning? So machine learning normally associated with deep learning or AI or business intelligence or data mining, knowledge discovery, and so on. Okay, so we will try to define machine learning based on how it relate to other term that we have heard before. Okay, so these are the terms that we have: machine learning, data mining, statistics, knowledge discovery, AI, and business intelligence. So by today, you should be able to differentiate between machine learning and other terms that you have heard before. Okay, so you have taken this one, right? Statistics. You also have taken data mining and AI, right? Okay. So,
Yes, doctor.
so since you have taken AI, so what are the intelligence that we are talking about here? Artificial intelligence. So what is the definition of AI? So AI is a systematic study on how we can imitate human intelligence, right? So what is human intelligence? What is number one? When you wake up every day, what is the first thing that you think? You plan, you think about what you want to do today, right? Do you have class? And then after that, where you want to go and so on. So this involve planning. So you have planning and reasoning. Okay. Second one, what makes us intelligent? Okay. So since you know how to plan and then reasoning, you need to be able to express yourself, right? So that is what we call we use natural language processing to express our thought. So this is what we call NLP. You already take this course, right? Um, Text mining lah. Okay, so this is natural language processing, and the third one is what? Okay, okay. For us to be able to do the perception about certain issue or certain matter, we need to be able to see, right? So computer vision is one of them. So for us to be able to plan or reasoning, we need to be able to get the input from our um, what we see outside there. So this is computer vision. Okay, so these three are part of the AI that they're trying to mimic. Okay, so they put the robot and then they say, can the robot to do planning and then reasoning? Can the robot communicate with us, or can the robot see things and then decide what to do? Okay, so that is the AI. Okay, let's go back to the machine learning. So what is machine learning? So machine learning is basically a program. This is a program that you will learn how to code them. So the main thing is to extract hidden pattern or to learn some hidden knowledge that we have from the data that we have. Okay, so this is just a program. So for example, you want to do classification or clustering or forecasting. So you write a coding to be able to classify or to be able to forecast or predict. So machine learning is just a program. Okay. So they focus on the development of the computer program that can access data and use it to learn the frequent pattern that we have from the data. And basically, in order for them to detect or extract the frequent pattern, they will use statistics. Okay? So statistics is a study on how to collect, organize, analyze, and interpret numerical information from data. So you have descriptive statistics, you have many other calculations that can be used by the machine learning. So machine learning is a program that use statistics to extract hidden knowledge. Okay? We also have this data mining. So data mining is a practice of applying machine learning. So basically you apply machine learning to extract knowledge. Okay? So this is applying the machine learning. Okay, so it depends on the task for the data mining, whether you want to do forecasting or classification or clustering. So you will apply certain method, certain program, certain code that we have to call from the library. Okay, and we also have this AI. So since machine learning is just a program that learn the data, so this is part of the AI that we have. Okay, so this is basically a subset of AI because they want to learn the data by themselves by using statistics in order to mine certain information that they have in the data that we have. Okay. Okay. We also have this business intelligence, but they are basically the same with machine learning or data mining, but this one mostly apply in the financial world. So they make use of this machine learning to extract knowledge. So they apply this one to extract knowledge. So this is mostly in financial. For example, they are doing customer segmentation, or they want to forecast, or they want to do market basket analysis. Okay. And lastly, we have this knowledge discovery. So this knowledge discovery is a big umbrella that cover data mining. So basically, knowledge discovery is the science of finding pattern within set of data, and data mining is part of the knowledge discovery process. So if we zoom into this knowledge discovery, we will have this. So you all are doing FYP1 this semester, right? So these are some of the process that you need to go over. So for example, in the first part here, you need to know what is the objective, what you want to do. Okay, you determine your project objective, and then how to assess the product that you are developing, and then what is the main goal, what you want to solve. Okay, so for this one, business understanding is to get or to increase profit, or you want to get more customer, and so on. Okay, so once you have set your objective, then you need to know what data you want to collect. So some of you I've asked, what is your data sets? So where do you want to get the data sets? And also it's better to get a local data set because it's primary data, and at the same time also it's more related to local issue in Malaysia here. You can get data from Kaggle or from somewhere else, but that is not so close to our situation in Malaysia. So if you have primary data, it's better. Okay, so you will try to collect data, describe them, and explore what kind of data that you have. Then you may have to do some data preparation, like data cleaning, you construct the features, or you combine the features in order to get a better result. Okay. Then the data modeling is basically selecting the model, and then you go for the training and testing phase, then build the model, and you try to improve the quality of the model that you produce. Okay? So this is where the data mining occur, in which you are trying to extract the frequent pattern that we have. And once you have built the model, of course, you need to evaluate. So if you satisfied with the accuracy or the lowest error that you get, then you can deploy. Okay, so deploy means you develop the apps, or you want to build a web base, so you have a GUI for them to apply your model here. So in this course, you will basically learn the whole process here, especially this one. Okay, so how you need to learn or figure out how do you get a good GUI for you to apply the model that you have proposed in the project. And if you select your data set depending on the domain that you have selected, then you need to have the complete circle here. So this is called cross-industry standard process for data mining. So very standard. Okay. Any questions so far? Okay. So if no question, let's proceed with the big data. We just define what is the big data, since all of you will need your own data to do the project. So depending on what project you want to explore. So what is big data? Big data can be defined using 5V. So the first one is volume, the size of your data. So nowadays we have images, we have videos, so they have a big volume of capacity that you need to store in your database. And we also look at variety. Variety refer to the type of data that you have. Some are you have video, images, text, or just uh, relational data, and so on. We also have velocity. Velocity refer to data coming from sensor, because they keep coming. So how do you process them? How do you perform the data mining for incoming data that is always running? So this velocity coming from the sensor data. Okay, and we also have value. So value refer to the cost of your data. So some data can be captured at certain time or specific frame of time. So, and maybe you need to spend a lot of money to go outside to the field or hire people to collect the data. So that is the cost of finding and then extracting useful data. So you pay people to do collection, modeling, and so on. And the last one is veracity. Veracity refers to inconsistencies and uncertainty in the data, in which the data could be valid only for certain time of frame. For example, for the exchange rate, you can use today's exchange rate to perform any modeling. After that, it's not valid anymore, because tomorrow we will have different exchange rate. Okay? So these are the 5V of big data. So as I mentioned just now, you have your data, you have your machine learning, you have your domain. So the domain refer to whether you are in agriculture, education, healthcare, or in biodiversity, aquaculture, and many more. So you have all this data, machine learning, and domain. So what you need to do is you need to deliver intelligent features. So this is something like you want to be able to perform clustering or prediction or forecasting or intelligent search, recommendation engine, and so on, or bots. Okay, so these are some intelligent features that we are discussing when we talk about AI. So, so our aim is to produce this. But before we can produce this, we need to learn what is machine learning. Okay, how do we apply the data that we have, and the data here coming from the domain that you will select later on. So if we look at the component of machine learning, so machine learning is basically a subset of AI. Okay, so in machine learning we have a few type of machine learning. So the first one is supervised learning, second one unsupervised, and also deep learning. So deep learning is a subset in the machine learning because they have more varieties here. And last one we have reinforced learning. Reinforced learning is a learning process in which you apply what you have learned yesterday for today's learning. So basically you have some kind of memory to remember what you have learned before. For this one, we do not have memory, but we learn based on the data given on that particular day only. Okay, so we have supervised learning. So this one means that you perform regression and also classification. Unsupervised learning, you are doing the clustering. Okay, this is the clustering. So this is the classification and regression. So this is the clustering and also the association rule. Okay, so deep learning can perform this or this. And like I mentioned before, so reasoning and planning and the natural language processing and the CV. Okay, so this is another illustration. So this is your big data. So big data, there are some overlapping in which deep learning, machine learning, and data science can be used to explore your big data. And the whole thing is part of AI. If you look at this one, some of them are not part of AI, which they refer to statistics method. Okay. So this is some of the top application of machine learning. Try to identify spam, image and video recognition. So this is like face recognition, um, face expression recognition, signature recognition, and so on. Okay. So we also have virtual personal assistant. We have sentiment analysis. So this one is looking into positive and negative sentiment. We also have fraud detection for the transaction. We also have customer segmentation or customer clustering. We look at the demand forecasting. For example, the consumption of agro food in Malaysia. You want to forecast how what is the consumption of the food in the next 5 years, and also this customer service automation. So this is like the bots lah. And this is recommending product based on your transaction history. Okay. So like I mentioned just now, we have the 4 types, so we will focus on these 2. So for example, for the supervised learning, we are looking at forecasting the housing price. So this is regression. Also classifying medical imaging, this is classification. This is customer segmentation, we use clustering. Okay. And then the market basket analysis, we use association rules. Okay. So for semi-supervised learning, we have a mixture of supervised and unsupervised. For example, this supervised, they have label. This is a guidance that the method use in order to perform the supervised learning. But in the unsupervised, because we do not have any label, label is just the class label. So you will learn more about this later on. Dia tidak ada label. So for that reason, we perform clustering only, grouping them into groups depending on the characteristic of the item or the product that we have. And for this one is a mixture of label and unlabeled. So we have text classification or land finding on GPS data. Okay. Okay. So to give you an overview how supervised and unsupervised learning difference, so we will look into this to just an overview from the top. Okay. So in the first one, supervised, so supervised learning. So what happened is that we have training data with target variables. Target variables means the class label. So we use the class label to learn the data so that we can perform classification. We have a series of numerical values, then we want to focus what is the value in the next 5 stages. So we have a guideline. Okay, so we use this supervised learning, and then once we have the model, then we have input, then we try to predict what is the class label that they belong to. Okay? So for this supervised learning, they must have label. Okay, so if you compare with the unsupervised, this is just the example. So we have this one is we have positive and negative sample. So how do we classify them? We need to be able to draw this boundary to say that, okay, whatever above theta 2 or whatever above theta 1, so they belong to positive sample, which is low risk customer. High risk when you have lower than theta 1 and theta 2. So this is the formula that we have. Okay, so when we say modeling, basically we want to draw the line that separates the two classes. Okay, so this is the robot that I have visited in Japan few years back. I tried to communicate with this robot, but the robot is trained using Japanese language only. So its name is Pepper. But nowadays, I think China has overtaken Japan in terms of building robots. Okay. So for classification, we can use for face recognition, character recognition, speech recognition, medical diagnosis using images to classify disease, biometrics, for example, face, thumbprint recognition, or outlier detection. Okay, so that is for classification. And we can use the supervised learning to use for prediction of future cases. So example, we have trained the model. So in future, if we have new data, then we can predict the class of that particular data that we have. We can use the supervised learning also to extract certain rules. You will learn that one later on when we learn decision tree. Okay. We also use supervised learning for compression. For example, these rules can be simplified using simplified rule, compress the rule to become more compact. Means instead of having 2 or 3 you have one rule only. We can also use supervised learning to perform outlier detection. So outlier referring to pattern which is away from the frequent pattern, which is not similar to the frequent pattern that you have. Okay? And this is one of the supervised learning, which is the regression. So given the data that we have in the reds, we want to know what is the best line that can represent them. Okay, so for example, this one we want to model the price depending on the mileage. Okay, so the lower is the mileage, the higher is the price. Okay, so this is the formula that's derived from the line. So depending on the value of the mileage, which is this one, you will get the price. So this is a sample of supervised. We will learn about this regression more. So this one is another one in which they try to predict the position of this object when we have different one, different x. Okay, so this is the so for them to derive this path, so they need to have more data that they have. For example, for these two, you would have more data that we have to derive this line that describe the movement of this kinematic of a robot arm. Okay, so when we compare to unsupervised, so unsupervised learning, we do not have any pre-existing label. We do not have any target label. Okay, so without target label. So we use machine learning basically just to group them or to cluster them based on the content of the item. So we are doing the grouping and clustering. So when we have new data here, then you will have to group them into the group that we already have. So the data will be grouped into no. Yes. So the new input will be into the most similar cluster. So every time we have new data here, that means we need to recluster them. Then we have data group into different cluster. Okay. So we will learn more about this clustering. I think you have learned that one before. So them, so machine learning, we focus on supervised and unsupervised. So we will learn all these three. So depending on the type of data that you have, you need to be able to determine which method is the best one. Okay. So in trying to model your data, basically you have training and testing model. So in the training phase, basically you have the input. This is your independent variable, and this is your non-target data. This is your dependent variable. Okay. So once you train the model, for example, you have this neural network, you will use this neural network here using the test data that you have, and then you will have the output here. So you want to compare with the actual data that you have. So in the testing phase, you want to compare the predicted values versus the actual values. So we have the accuracy. So once we have tested them to get the best setting, then we can deploy them. So we build GUI for this neural network, and then given the new input here, then we'll produce the output. Okay, so this is the big scenario that you need to go through. Okay, and of course, this is how we evaluate our model. So we have this, what we call it. So if your this is your predicted value, this is your actual value. Okay, so if your predicted value is true and then the actual is true, basically they are matched. So this is what we call true positive, because they match. True positive. Okay. If the actual is false, but you predict them as true, so this is false positive. Because you predict them as true, but this is false, so false positive. If the actual is true, but you predict them as false, so this is false negative. Okay, if the actual is false and then you predict them as false, so this is true negative. Okay, so we use this one to build the accuracy. Okay, so this is the basic data modeling that we have. So this is what we have discussed in the knowledge discovery. You need to look at what is your objective, prepare your data, and then plan what model you want to use. You train them, and then you deploy. So this is the full cycle that we have. Okay. So remember just now we have true positive, false negative, false positive, and so on. So if your actual value is true and you also predict them as true, so this is true positive. So if your actual value is true but you predict them as false, then this is false negative. If your sample is false but you predict them as true, so this is false positive. Okay, and the other one is true negative, because false. So what we want to maximize here is this true positive and true negative to get your high accuracy. We do not want to have false negative and false positive high. Okay, so when we try to evaluate our model, so we sometimes we use this one, sensitivity, recall, hit rate. So this is equal to the true positive rate. Okay, so the true positive rate here, the formula is true positive divided by true positive plus the false negative lah, which is this. Okay, how many of the total positive is predicted as true positive? Okay, so how much of them has been recalled? We also have true negative, but this one is looking into the negative sample here. So basically this one is specificity is the ratio of true negative and the total number of negative. So this is the if this ratio is closer to 0, so this is good because we want to reduce the number of true negative. True negative rate, which refer to this true negative divided by, which is true negative divided by this, the total of this. Okay. And normally for classification, they use accuracy. So we want to maximize this true positive and true negative divided by the total number of data that we have. This is the number of data that we have. Okay. And in some research, they use precision and recall to analyze your result. So basically, precision and recall refer to the true positive. Okay, so for precision is we want to maximize this, which is maximized to 1. And so this is basically the true positive and false positive. How many of these true positive belong to the actual data that we have? And this one is similar to the precision, but this is referring to the false negative. Okay, and we also have the F-score. So this is a combination of precision and recall. So they just combine so that they have only one value. So those who have taken information retrieval, you learn about this before, right? So recall and precision. We also have this residual sum of square. Residual refer to errors that we have in your modeling. So this is basically finding the differences between the actual and predicted value. And you take the square because you want to remove the negative value here and take the summation. So this is the total number of square error that we have. Okay, so this is normally applied in clustering or forecasting. Okay, and we sometimes use correlation because this one will tell you whether your data can be used for forecasting. Okay, so this is linear regression. This is linear, but your variance is too big. Okay, so this is okay. So correlation is a statistical term describing the degree to which two variables move in the connection with one another. So we want to know the correlation or the status of linearity of your data that we have. So normally we use this one to check whether your data can be used for forecasting or regression. Okay, this is similar to what we have before. You see, this is the predicted value minus the actual one, and you take the square, but you take the average. Okay, so you take the average. If you compare with this is just the sum of square error. This is the mean square error. So we take the average. Okay, we also look at this one, receiver operating characteristic, in which we want to evaluate the model that we have. So we have, if we look at here, okay, this is true positive rate. This is false positive rate. Okay, so if your true positive rate is here, so that means your true positive is bigger. So you want to move the curve going to this direction, because we are saying that when you are at this position, you have 100% true positive correctly classified. Okay, we do not want to have here because this is false positive. So what we are saying here, on the average, we have this line, but all the model that we will have, we have to evaluate and plot them. So if you see model which is nearer to this point, will be a better model because we have higher true positive. Okay, true positive is when your actual is the same as your predicted value. So for the unsupervised learning, we normally group them. We do not have any label. We can use the association rules in order to extract the pattern that we have. So example of application could be customer segmentation. This is we're trying to compress certain, like for example, you have 3 column, you want to compress them to become 1 column. Okay, so depending on the value of each of these column, for example, X, Y, Z, so we have only A here, so we are compressing 3 column to become 1 column. So we use the clustering. Okay, and this is bioinformatics. We look at the sequence of data that we have. So the sequence of data, for example, like this, compare with this, and we have new data here, something like this. So we want to determine whether they belong to this pattern or this pattern. So we can use the the characteristic that they have. So you will learn more about this later on. Okay. This is another one. This is the clustering. We also can use this market basket analysis. Given X, what is the probability of having Y? So, for example, if you buy given a beer, what is the probability of for you to buy chips? Okay, so 0.7. So this is how we trying to perform the market basket analysis. Okay. So overall, if you look at the machine learning here, we have classical learning. So we have supervised and unsupervised. So we have classification, regression. We have clustering, and also we have this dimensionality reduction. And also we have pattern search. Pattern search, we use this for market basket analysis. Okay, so we will learn all this, and we also learn part of this. Okay, and also we learn about this. This is where you combine a few models to become your meta classifier. Okay, so if you look at the area that we have so many model, but we do not have time to study all of them. But once you learn one model from the artificial neural network, then you can relate to the other variant of neural network. Okay, this is if we follow the Microsoft Azure. So we have this. We start from here. So if we want to predict future data point, so this is predict. So if you don't do prediction, you go to clustering. If you do prediction, then you want to know whether you are dealing with numerical value or categorical value. If you are looking at numerical value, then you go for regression. So if you're looking for categorical value, then you go for multi-class or two class. So this is two classes or more than two classes. Okay. So these are some of the paths that you need to look into when you perform the modeling, either clustering or regression or multi-class classification and two-class classification. Okay, so this is another view. So basically we have classification, we have clustering, we have regression, we have dimensionality reduction. This is to simplify your data set by looking into PCA or the kernel approximation. So this one we will not touch. So we will cover this drill. Okay. And this one also show you, okay, we have regression, we have neural network, we have ensemble, we have deep learning, Bayesian, decision tree, instant based clustering, so rule based. So all this we will learn. Okay, so we will learn. We won't be covering this one and this one. Okay. So we also look at how do we divide the tasks that we have. So, for example, we may have a linear problem in which we are looking at what is the best fit line through our data. So we use linear regression, or if you want to use classification, we can use logistic regression. For neural network, they can perform both of these. You want to do regression or classification, they are neural network can cover both. Okay, so the good thing about neural network is they are more flexible. For decision tree, we will learn about decision tree. Once we have one model, decision tree, we can have multiple model. Later on, you will learn about that. So if we have multiple model of decision tree, then if we combine, it will become random forest. Okay, so we have another variant of tree, which is the gradient boosting, in which we use weaker decision tree to cover the misclassified data that we have. Okay. So this is some of the sample that we have. I think I've shown you before. This one we're trying to estimate the weight of the cattle based on the image that we have. This one we try to predict the health of the beef cattle based on the movement. We put sensor, and also we based on the weight that they have. This one we are looking into the carbon stock estimation based on the hyperspectral images. So we use CNN to classify the image, and we total up the number of carbon stock estimation. We also use the hyperspectral images to look at the health of the paddy field. Based on the vegetation index that we extract from the image, we can focus on those areas which are not producing healthy paddy. And this one is with Dr. Renner. I think you met him before, so he was my student, now become the faculty member. Okay, so the challenges at the moment is that not many people know about machine learning, but they claim they know. They talk about AI, but basically they don't know what is the work behind AI. Okay, so lack of awareness among the top management. We have non-integrated system where we have so many island of system, so we need to integrate them. We do not have enough data to model our um, algorithm, and then poor data capturing and storage, and also we do not have local expertise. So you guys will be the local expertise once you have graduated from here. Okay, so so that is the overview of this course. Any question?